The goal of this tutorial is to show step-by-step configuration of an example of advanced Metro high availability cluster with two OpenE JovianDSS data storage servers. This active-active cluster configuration uses servers with their own storage as directly connected SATA drives, which are mirrored over Ethernet to the other node. In this tutorial, we're going to use a bond network interface made of two Ethernet interfaces for iSCSI targets and SMB and NFS share exports. Bond network interface should be preference choice for SMB and NFS shares, but for iSCSI path redundancy, MPIO is a better option. If your system works as unified storage appliance with both NAS and SAN storage, and all these services require path redundancy, then configuring two bond network interfaces will be required. In such cases, the iSCSI path is set up via its own bond interface. However, for the sake of simplicity in this tutorial, we're going to show a configuration with single bond interface. Another important configuration details is use of 4 disks for each mirror disk group, 2 local and 2 remote. This is to ensure disk redundancy for each group, even in the case of failover. But please note that although this configuration is very safe, its efficiency is only at 25%. Out of every 4 identical disks, you can only effectively use the data storage capacity of 1. To increase that efficiency, you can use a hardware RAID controller and create the disk group from 2 disk units with these RAID arrays behind them. Okay, so let's move now to configuring the cluster. On your first cluster node, select System Settings from the main menu, and next select the Network tab. Click on the Create Bond Interface button. Select 2 network interfaces from which you would like to create the bond interface. Select its type and primary interface. Provide its IP address and click on the Apply button. Next, enter all required details for the second bond interface and also click the Apply button to confirm the changes. Two bond network interfaces have been created successfully as shown on the interfaces list. Next, select the Change button on the default gateway group of options. Select one of the newly created bond interfaces and click the Apply button to confirm the changes. Now, open the web GUI of the second cluster node and create 2 bond interfaces similarly as on the first cluster node. For the cluster to work correctly, it is important that both of its node systems' times are synchronized. On the first node, go to the System Settings, select System tab, and in the Time and Date Settings Options group, select Continuous NTP Synchronization. Click Apply to confirm the changes and then repeat these steps on the second cluster node. Move back to the first cluster node. Go to the Failover settings and in the Failover status group of options, provide IP address of the bond interface on the second cluster node. Administer password for the second node, and click the Connect button. The bond interface will function as a ring path or heartbeat and a ping path. It must go through the network switch and ping nodes must be external to the storage nodes. It is not allowed for the ring to use nodes point-to-point connections, otherwise the cluster may run unpredictable and you put the integrity of your data at risk. Once the connection is established, you'll notice the available options in Failover settings have changed. Click Edit button in the Ping Nodes section and enter the IP addresses of at least 2 ping nodes. Ping nodes' IPs must be reachable from the ring interfaces, therefore they have to use the same network subnet as ring interfaces. Next, click the Add Mirroring Path button. In the dialog that will appear, select an interface from local and remote cluster node and then click the Apply button. Now, select Storage from the main menu. In the Unassigned Disks table under the Local Disks tab, there will be all local disks listed. That is, the disks available on the cluster nodes on which you are currently working. Disks available on the second cluster node will be listed under Remote Disks tab. To create a new Z-pool, click Add Z-pool button. First, you will create data groups, that is, groups that will actually store your data. Add each data group by selecting 4 or 2 disks, then selecting Mirror Single Group from the Redundancy pull-down menu, and then clicking Add Group button. It is recommended to set 4 disks, 2 local and 2 remote, for each mirror group because in case of a reboot or failure of one of the cluster nodes, the remaining mirror groups are still redundant and protect your data against disks failures. However, a 4-way mirror provides very limited storage efficiency of only 25%. To increase that efficiency, you can use a hardware RAID controller with simple 2-way mirror with RAID array behind each of the disk units. Repeat the steps of adding data groups as many times as necessary to reach the desired storage size, and once finished, click the Next button. Create a single write log group by selecting 2 disks, 1 local and 1 remote, and then click Add Group button. You don't have to change the default mirror redundancy settings. Once done, click the Next button. For read cache, please select 1 local SSD disk and click on the Add Group button. Again, you don't have to change the default single redundancy settings. Once done, click the Next button. Click the Next button. On the Z-pool Properties step, provide a name for the new Z-pool. Once done, click the Next button. The summary screen shows all the details of the Z-pool that is about to be created with options to move back to any of the previous steps if necessary. Click Add Z-pool button to finish creating a new Z-pool. Newly created Z-pool appears on the storage screen. Go to its Virtual IPs tab and click Add Virtual IP button. Enter the new IP address, assign it to both local and remote bond interface, and confirm by clicking the Apply button. Select System Settings from the main menu, and in the first Administration tab, scroll down to the Critical I/O Errors group of options. It is strongly recommended that the option Immediate is selected in order to execute immediate system reboot in case of critical output errors on the disk. Now the cluster is ready to start. Select Failover Settings from the main menu and click the Start Failover button at the top of the page. The process of starting the service may take a while, but once done, the failover status should show Started. In order to effectively manage the cluster and to be able to respond in case of failure or malfunction, it is vital to have properly configured monitoring and notifications. First, email notifications. Select System Settings from the main menu and scroll down to Email Notifications group of options. It is also highly recommended to set up the system monitoring with Remote Log Server or SNMP. You can configure it directly below the email notification settings. Once the failover is configured, you may want to test it to see if it works as expected. Select Storage from the main menu, and from the Options menu on the Z-Pool, select Move. The Z-Pool is shown as exported on the current cluster node. At the same time, it is imported to the other node. In order to restore the Z-Pool to the current node, click on Move to this node button. Now that the failover test is completed and the Z-Pool is active back on the current cluster node, you can start creating iSCSI targets and/or NFS or SMB shares and connect storage clients. Once storage clients are connected, you can run one more failover test with reboot of the first cluster node and then with the reboot of the other cluster node. You can modify this tutorial for other configurations as well. For iSCSI initiators with multipath, you can use setup with 2 storage access paths and 2 virtual IPs. It can also be used without multipath, just to separate the load on 2 separate network paths. Instead of 2 storage paths, you can use 2 bondings. Such setup can be used for iSCSI initiators with multipath or for mixed iSCSI, SMB, NFS environments. Another variation of the setup is to use point-to-point round-robin bond instead of single Ethernet connection. This provides better reliability and better mirror performance. To learn more about data storage and high availability solutions, please visit website address shown below.